Okay, so let's go ahead and piece this together for one more. I threw some little nuances in this one that we have to pay attention to, so it'll just be a little bit harder, but it basically, again, comes down to manipulating data. So the first thing, again, is figure out who's who. So the first thing we have is our A is -5. So the amplitude, right, is 5. Okay, so this just means that we're not only stretching the graph, but we're reflecting it around the x-axis. So cosine usually starts at a high point, so that high point is now going to start at a low point if we are, looking at things because of the reflection through the x-axis. Here we have that c is equal to 8, so my equilibrium is basically y equals to 8. So we've got all the stuff that impacts y. Now here's what's challenging about this, right? Because the way that I've been putting this together, we usually have b parentheses x minus d. But what I again have is there is no parentheses around this. This pi is applied to that x. So we need to change it like this. So how about, let me bring the work over here. When I look at this, all I simply have to do is factor the pi out of there. When I factor that pi out, we get left with x here and 1/2 there. So this is -5 cosine of pi x minus 1/2, right, plus 8. And now it fits the form that we have. So our b is equal to pi. So our new period, right, 2 pi over pi is 2. So that's kind of nice. Our period is basically nice numbers. Okay, we're going from 0 to 2 pi, and now our period is 0 to 2. So that's a pretty nice, we're kind of almost back to some nice normal numbers and not dealing with any, it's still radians, but nice radians. And then our d, right, looks like it's equal to 1/2. We're subtracting it, so again that means we're moving to the right 1/2 unit. So manipulating data, right, so again we're going to take on a cosine graph. We have 0, 0, 1. We have pi over 2, 0. We have pi -1, 3 pi over 2, 0, and then we have 2 pi, and we're back at 1. So those are the typical points. So what's happening first? Well, multiplications and divisions. So to start doing this, we're going to multiply all these by -5, right? Because that's what A is. And here we're going to divide by pi. Okay? So we're dividing everything through by our pi, which means we're actually multiplying everything by 1/pi. So when we do this data, right, what we get is 1/pi times 0 is 0. 1 times -5 is -5. 1/pi will cancel out, leaving us with 1/2. 0 times -5 is 0. 1/pi times pi is 1. -1 times -5 is 5. 3 pi over 2, if I divide it or multiply it by 1/pi, the pi's cancel out. We're left with 3/2. 0 times -5 is 0. Multiply by 1/pi, we get 2, right? And over here we get 1. So you can see we're going from 0 to 2, right? And we broke it up in some nice quarters. Again, you can hopefully just kind of visually see that in terms of our interval. So we've handled the A and the B. What about the C? Well, we're now going to take all our Y values and add 8 to them, because that's what C is. We're going to take all our X values and add 1/2 to them, because we're moving to the right. So doing that work, we're going to get the new data points. -5 plus 8 will give us 3. 0 plus 8 is 8. 5 plus 8 is 13. 0 plus 8 is 8. 1 plus oops, I think I screwed up there. That should have been a -5. -5 plus 8 is going to give us 3. Okay, so 1 times -5 was -5. I just wrote down 1. Here we're going to add a 1/2 to everything. So 0 plus a 1/2 is 1/2. A 1/2 plus a 1/2 is 1. 1 plus a 1/2 is 3/2. 3/2 plus a 1/2 is 4/2 or 2. 2 plus a 1/2 is basically 5/2. Okay, and so there is your data that we need to plot one cycle of this crazy cosine. So what we'll do is just come, it looks like a good scale. How about I'll just fit it here. So a decent scale here it looks like we're way above on the y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15, and there's 1, 2, 3, 4, 5, 6, 7, 8, and there's 8, right? The reason why I'm kind of highlighting 8 is we know 8 is the equilibrium. So I'll just kind of sketch that in there. And so on my y-axis, how about I just go 1 and 2 and 3, and of course we have all their halves in there as well. So when I go graph this at 1/2, we are equal to 1, 2, 3. We're equal to 3, right? At 1, we're equal to 8. At 3.5, we're all the way to 13, which is about there. At 2, we're equal to 8, and at 5.5, we're equal to 3. So here is one cycle of this graph. Of course, we can continue on in this fashion and create more cycles, but there for sure is one cycle and all the data that's given, right? We can clearly see where the high point's occurring. It's occurring at 3/2 13. We can see where these low points are occurring at 1/2 3 and 5/2 3, and we can even see where we're crossing the equilibrium at 2, 8 and 1, 8. Alrighty, we see the equilibrium in play. We see that we're 5 units above it and 5 units below it, right? So we see the amplitude of 5 in both directions. Okay, so everything is pretty much there, everything we need to see. So kind of a nice sketch, and there you guys have it. So it's all about manipulating data. Take your core data, do what the A, B, C's, and D's tell you to do. We spent a lot of time telling you what they do. Let them do the math, and then all you got to do is put a nice sketch together with your scales, and it pretty much, I hope, almost seems too simple, all right? But it is a lot of work, but we'll get it right, okay? So that wraps that up. We're going to go off and do some more things here shortly, but there's basically how we get the graphing done. Talk to you guys later.